Good morning to all. In today's class, first we will complete interfaces. After that, I will start garbage collection. So already explained about interfaces. So the main important question when you go to interviews in Java is how do we achieve multiple inheritance in Java? Already explained in inheritance, Java does not support multiple inheritance. You know there are only three types of inheritances in Java. There are single level inheritance, multi-level inheritance and hierarchical inheritance. Java does not support multiple inheritance. Multiple inheritance means one class extends more than one class. Okay, but in Java it is not possible. In Java, one class can extend only one class. One class cannot extend more than one class. That's why Java does not support multiple inheritance. So when Java does not support multiple inheritance, how multiple inheritance is achieved in Java? This is very important question. C++ supports multiple inheritance, but Java does not support multiple inheritance. So how do we achieve multiple inheritance in Java? The answer for this question is through interfaces we can achieve multiple inheritance. Means one interface can extend more than one interface. It is possible in case of interfaces, but it is not possible in case of classes. See, again I am repeating. In Java, one class cannot extend more than one class, but one interface can extend more than one interface. So through interfaces, we can achieve multiple inheritance in Java. Okay, so interface concept is very important in Java. There are three important concepts in Java, or throughout Java we will study only with these three concepts. They are classes, abstract classes and interfaces. These are the only three containers available in Java. If you understand these three concepts thoroughly, that is classes, abstract classes and interfaces, then you can easily understand Java. So if you take any program in Java, only with respect to these concepts we will write Java programs. What are the three concepts which are very important in Java? They are classes, abstract classes and interfaces. So try to write number of programs on these three concepts, that is classes, abstract classes and interfaces. If you take any Java program, it can be in any one of these three concepts. That's why repeatedly I am saying in each and every class, the three important concepts in Java are classes, abstract classes and interfaces. So try to write as many programs as possible with these three concepts. Because Java is an object-oriented programming language, which is concept-oriented language. That is, if you take any concept, you should be thorough with that concept. Suppose if you take static, explain the static keyword in Java with example means first you have to write about static. After that, try to write at least one program on that concept. Similarly, abstract class. So first define what is abstract class and try to write one program on abstract class. Similarly, if you take interface, okay, explain interface in Java with example means first you should write what is an interface and how to write the programs using interfaces. Like that, inheritance means first write what is inheritance and what is the advantage of using inheritance in Java and what are the different types of inheritances which are possible in Java, and try to write one program on each type of the inheritance. Like that, we can use interfaces in multiple ways. Already explained in the last class. There are 7 ways to use interfaces in Java. Means 7 ways means we can write the programs, okay, using any one of those 7 ways. Okay, So we can write 7 different types of programs using interfaces. Last class I have explained one program on interfaces. In today's class I will explain some more programs on interfaces. After that we will go to garbage collection. So Java is very easy subject, because in the exam also you will get concept and one example on that concept. Like that you have here the concepts are like take the keywords like final, abstract, static, like that. In the exam you may get the questions like this. And polymorphism is also very important in Java. That is, there are 2 types of polymorphisms in Java, no? That is compile time polymorphism and runtime polymorphism. Under compile time polymorphism we have overloading. Again, in overloading we have 2 types: constructor overloading and method overloading. These 2 are very important for exam point of view. So what is constructor overloading? Explain with constructors, and after that write one program on constructor overloading. In the same way write one program on method overloading. Next, coming to overriding. So overriding concept we should explain with inheritance only. Without inheritance there is no concept of overriding. But overloading is explained with one class only. That's why inheritance is not required for explaining overloading concept. But inheritance is must to explain overriding concept. So you know method overriding. That is also very important in Java. So overloading and overriding are compile time polymorphism and runtime polymorphism. These concepts are also very important. Okay, like that. So you have to study, you have to see the concepts which are available in Java. Take one concept, let us take final. Explain final keyword with example in Java. Means how many ways we can use final. Already explained: final variables, final methods, final classes. Final variables cannot be modified, final methods cannot be overridden, and final classes cannot be subclassed. Explain like this. After that try to write one program on each of these 3. That is final variables, final methods and final classes. Like that, if you study the Java, take one concept and complete that concept. First, what is that concept and how to explain that concept. After that, try to write one program on that concept. So if you study like this, Java is very easy language. Compared to C, Java is very easy. Okay, that's why follow my notes and recordings. Okay, it is very useful for mid-exam as well as final exam. Go through the previous recordings, and already I shared the recordings and class notes in Google Classroom. Nearly I think 20 recordings are there. Please go through all the recordings. Listen the recordings carefully, and notes is also available. Means class notes. This is the class notes of my senior or your senior student, the last year student. Okay, means last semester I taught Java for CSE students, so I have collected the notes from her. So it is the good notes, so you can easily follow these notes. So go through the recordings and class notes, so you can easily write your mid exam also and final exam also. Okay, now coming to interfaces. Already explained the differences between classes, abstract classes and interfaces. Classes means don't call these as concrete classes. There is no such keyword like concrete. That's why understand classes, abstract classes and interfaces, and observe the difference between these 3 types. That is classes, abstract classes and interfaces with respect to variables and methods. Because you know in Java, no, that in any our class consists of only state part and behavior part. If you take any class in Java, it consists of only state part and behavior part. State part is nothing but variables, and the behavior part is nothing but methods. That's why differentiate these 3 types with respect to variables and methods. So which type of variables and which type of methods we can We can write in classes, or we can write in abstract classes, or we can write in interfaces. Coming to interfaces, interfaces consists of only abstract methods and final variables. That's it. So again, I am repeating the same statement. Interfaces consist of only final variables and abstract methods. You know the definition for abstract method and you know the definition for final variable. So after understanding the definitions of final variables and abstract methods, it is easy to write the interface programs. Okay. Already explained interface syntax is, interface is a keyword, interface is name is an identifier like class name. Okay. Now inside this interface, I can put only final variables and abstract methods. That's it. But by default, all the interface variables are public, static, and final, and all the interface methods are public and abstract. And the access modifier of the interface is default. The access modifier means here we will write. After packages, I will explain in depth about access modifiers. We have 4 access modifiers. They are private, protected, default, and public. So if you won't write anything for this interface, by default it is default access modifier. If you want to write, we can write only public access modifier for interface. And inside this, all the variables are public, static, final, and all the methods are public and abstract. By default, these keywords are available for variables and these 2 keywords are available for methods. This is about interface. Already explained how many ways we can write interface programs. There are 7 different ways. Okay. So program 1 is define one interface and take one class which implements that interface. Already explained. Whenever you write interfaces, because interface programs, because interfaces consist of only abstract methods. For abstract methods, there is no implementation. Without implementation, there is no use of defining the abstract method. No. The abstract methods must end with semicolon. There is no body for abstract methods. That's why somebody must give implementation to the abstract methods. That's why in abstract classes and interfaces, we will write abstract methods. That's why abstract classes must be extended. In the same way, interfaces must be implemented. Whenever you define interface, there must be one class which implements that interface. The role of this class is to provide the implementation to all the abstract methods of this interface. Okay, this is the first important program to understand interface concept. Once you understand this concept, remaining programs are very, very easy. So whenever you define an interface, always there must be one class which must implement that interface. Okay, how this class implements this interface is using this keyword implements. Between 2 classes, we use extends keyword. Between 2 interfaces also, we use extends keyword. But between class and interface, we use implements keyword. Okay, so extends and implements, these 2 keywords are very, very important in Java. Again, I am repeating. When we use extends keyword, between 2 classes, we can use extends keyword. In the same way, between 2 interfaces, we can use extends keyword. But between class and interface, we use implements keyword. Okay. And now this is the simplest program. Already explained this program in the last class. Now there are totally 7 ways. I will explain some more programs in today's class. Okay. And now here, what is the first program? Only one interface I have defined. After that, I have taken one class which implements that interface. The role of this class is to provide implementations to all the abstract methods of this interface. After that, one more important point to remember is, for interfaces, we can't create objects. For abstract classes and interfaces, we can't create objects. So now the question comes into picture is, without creating the objects for abstract classes and interfaces, how do we access the members of the abstract classes and interfaces? Already explained. Using object, first create the object, with that object only, or I can say like this. First, whenever you define a class, you need to create an object for that class. With that object only, I can access the members of that class. But for abstract classes and interfaces, we can't create objects. So without creating objects for abstract classes and interfaces, how do we access the members of the abstract classes and interfaces? That is the question. You have to answer, or you have to give the answer for this question. Again, I am repeating the question. Without creating the objects for interfaces and abstract classes, how do we access the members of the abstract classes and interfaces? And for interfaces and abstract classes, we can only create reference variables. We cannot create objects. Object means you have to create object with new operator. But for interfaces and abstract classes, we can't create objects with new operator. But we can only create reference variables. But with reference variables, we can't access the members of the abstract classes and interfaces. That's why to answer for this question, okay, we have to use upcasting. Already I explained upcasting in depth. So in case of interfaces and abstract classes, we must use upcasting. There is no other alternate. Okay, so with upcasting only, we can access the members of abstract classes and interfaces. Okay, already I explained in the last class how do we apply upcasting in case of interfaces. Okay, the answer for that is implementing class object is assigned to interface reference variable. Already explained, for interfaces we can only create reference variables, we can't create objects. Now upcasting is nothing but, already explained, whenever you define an interface, there must be one class which implements that interface. So for this implementing class, we can create objects. But for interfaces, we can't create objects. We can only create reference variables. Now I will use this interface and this implementing class, okay, to access the members of this interface. So now I will form a relation between this interface and this class. How do I form a relation between these two is, that is nothing but upcasting. That is, implementing class object is assigned to interface reference variable. So for interfaces, we can create reference variables, and for implementing classes, we can create objects. And now with these two concepts, I can form a link between this interface and this implementing class. That is, the link is nothing but upcasting. That is, implementing class object is assigned to interface reference variable. With this reference variable, I can access all the members of this interface. If you understand this concept of casting, okay, you can easily understand abstract classes and interfaces. If you don't follow this upcasting, it is very difficult to follow the programs on abstract classes and interfaces. Because for abstract classes and interfaces, we can't create objects. Without creating objects, we can't access the members of these two. That's why we must use upcasting whenever you write abstract classes programs and interface programs. Okay. Now, this program already I completed. Now I will explain this. Here I am defining one interface and I am taking one class which implements that interface. After that, I am taking one more class which implements the same interface. Here there is only one interface and two classes are implementing that interface, and these two classes A and B must provide implementations to all the abstract methods of this interface I1. After that, now assign class A object to interface reference variable, again class B object also to interface reference variable. Okay, so how do we write upcasting with respect to I1 and A and with respect to I1 and B? Now I will explain. So I1, small I1 is equal to new A. With this reference variable A, I can access all the members of I1. Similarly, in the same way, when you take this B, so I1, I2, take the different reference variable. Don't take the same reference variable. Here you should differentiate these two classes with respect to two reference variables. That is, I1 is equal to new A. Next, I1, I2 is equal to new B. Okay. So like that, we can write the program using this concept. You can write the programs on your own only once you understand the concept. Next, what is the third program? I am defining two interfaces. See, two different interfaces I am defining. Next, I am taking one class which implements these two interfaces. It is nothing but multiple inheritance. So one class can implement any number of interfaces, or one interface can extend any number of interfaces. Both are possible. One class can implement any number of interfaces, and one interface can extend any number of interfaces. These two are possible with respect to interfaces. Next, what is the fourth one? Fourth one is two interfaces we have defined, and one class I have taken, class A, and with inheritance also I can explain. Class B extends A, means inside B, okay, all the members of I1, I2 and A are available. So here we have included inheritance. Okay, means we have used inheritance concept and also implements. See, in the same program I am using extends and implements. Means I am defining two interfaces and one class, and I am taking one more class which extends this class A. Means all the members of class A are inherited to this class B using extends keyword, and all the members of interfaces I1 and I2 are inherited to this class B. So class B can make use of all the members of class A and all the members of the interfaces I1 and I2. Okay. Next program means interfaces can also be extended like classes. So here interface I1 and interface I2 extends I1. So between classes we can use extends keyword, and between interfaces also we can use extends keyword. If you take here one interface we have defined, and I am taking one more interface I2 which extends I1, means all the abstract methods and final variables of this interface I1 are inherited to this interface I2. Okay, so I2 can use its own members as well as this implementing this interface I1 members. Okay, inside I2 we can use the members of both I1 and I2. Okay, next, sixth one is I am taking two interfaces. I am taking one more interface I3 which extends I1 comma I2. This is also multiple inheritance, means one interface can extend more than one interface, but with respect to classes it is not possible. That is, one class cannot extend more than one class. Like class C extends A comma B. I have three classes A, B, C. I will form a relation between these three classes like this. Class C extends A comma B. So it is the wrong syntax in Java, because one class cannot extend more than one class. That's why multiple inheritance is not possible in Java. But through interfaces we can achieve multiple inheritance in Java. That is this program only. First I have defined two interfaces, and then I am taking one more interface which extends these two interfaces I1 and I2. So here what is I3 means? I3 can access the members of I1, I2 and its own members, that is I3. Okay, this is important program to understand multiple inheritance. Next, last program is inside using in interfaces we can use abstract classes also. Okay, in the same program we can write abstract classes, normal classes and interfaces. So if you see this program, here in this program we are using all the three concepts of Java, or all the three containers of Java, that is interface, abstract class and class. So if you see this program, so here I am defining one interface I1. Next, I am taking one abstract class A which implements I1. Why I should take this class A as abstract is because this class A doesn't want to implement all the abstract methods of this I1. This class A wants to implement only some methods of the interface I1. Actually, the rule is that when class A implements I1, the role of this class A is it has to provide the implementations to all the abstract methods of this I1. But here in this case, this class A doesn't want to provide implementations to all the abstract methods of this interface. So in that case, this class must be declared as abstract, because the abstract methods are inherited as it is to this class A. If the class won't provide implementation, means the abstract methods of this interface are inherited as it is, like abstract only. Already you know abstract class concept. If a class, okay, which contains at least one abstract method must be declared as abstract. When this class doesn't want to provide implementations to all the abstract methods of this interface, means some abstract methods of this interface are inherited to abstract only for this class. Means this class A contains some abstract methods. The rule in abstract classes is, if a class which contains at least one abstract method must be declared as abstract, otherwise you will get compiler error, syntax error. That's why this class A contains some abstract methods, no? That's why this class must be declared as abstract. So here the abstract class A implements I1. Next, after that, whenever we have abstract classes, the abstract classes must be extended. Means there must be one subclass which extends this abstract class. That's why I have taken class B extends A. Means here in class A we have some abstract methods now. So the class B will give implementations to the abstract methods of this class A. That is the concept of this. In this program you can understand, you can see all interfaces, abstract classes and classes. All the three containers of Java we can observe in this program. Okay. Now between classes and interfaces we can use extends keyword, and between interface and class, or class and interface we can use implements keyword. Next, first program already explained. Now I will explain the next program. Once you understand the concept, programs are very easy, no need to by heart. See, program 7 I will explain. What is the 7th program? It uses all the three containers now. See here, if you see this hierarchy, I1 is interface, A is abstract class, and B is class, means concrete class. We can see all the three containers. So here why A is abstract class is, A is not providing implementations to all the abstract methods of this interface. That's why the class A must be declared as abstract. For abstract classes, we need to take one class which extends abstract class, and in this class we will provide the implementations to the abstract methods of this abstract class A. If you understand this hierarchy, writing the program is 1 minute. So interface I1. First we have to define I1 now. This is interface, this is abstract class, and this is concrete class. Okay. We will see this hierarchy. Okay. Now first we have to define I1 now. So in interface I1, I am taking one final variable A, that is public static final. You no need to write these three keywords. By default, these three are available for all the variables inside the interface. Here I am taking one final variable A, and it is assigned with temp. Next I am taking two abstract methods, they are M1 and M2. These two keywords are also by default available. If you won't write, by default available. If you write also, no problem. Here inside this interface, I have one final variable and two abstract methods. You remember the definition of interface. So inside interface I1, I have taken one final variable and two abstract methods. And now we will see this class A. So class A implements I1. Means the class inside class A we must provide implementations to these two abstract methods now. But class A is providing implementation to only one abstract method, that is M1. See, if you observe, it is giving implementation to only one method, that is M1. It is not giving the implementation to M2. Means this method is inherited as it is to this class. Actually no need to write this. Okay, by default this M2 method is inherited to this, but for your understanding I have written, actually no need to write this statement. So here this abstract method is inherited as it is, because this class A is not providing implementation to M2. It is providing implementation to only one M1. Actually this class has to provide implementation to both the abstract methods of this interface I1 when it writes implements I1, but it is providing only one implementation for one method, and it is not providing implementation to the method M2. And already last class I explained, whenever you give implementation to the interface method, you must write public. The access modifier of the overriding method must be greater than or equal to the access modifier of the overridden method. In case of M1, it is called overridden method and it is called overriding method. So the access modifier of overriding must be greater than or equal to the access modifier of the overridden method. Here for the overridden method, by default public is available. Here there is no other alternate, you must write public only. Greater than or equal to means we are using public. Okay, that's why it must be public. Suppose if you won't write public, you will get error definitely. Okay, whenever whenever this class implements this interface, inside that it will provide implementations to all the abstract methods now. So for all the abstract methods, it has to take the access modifier as public. This is the rule. Next, in addition to so inside class A, what I have written already, one variable, that is this A is inherited to this class A, means A is available to this class A. In addition to that inherited variable, it can write its own variable, that is B. So inside class A, two variables are available, they are A and B, and it can write, in addition to the implementations of the abstract methods of the interface, it can write its own method. M3 is the own method of class A. Okay, this is the why we should declare this as abstract is, this class A consists of abstract method. The rule is that if a class which contains at least one abstract method must be declared as abstract, otherwise you will get compiler error. That's why I have declared this class A as abstract, because it contains one abstract method M2. Okay. Next, after that, so because inside this abstract class A, I have one abstract method now, means somebody must provide the implementation to this method M2. That is the first point. Second point is, for abstract classes, we can't create objects. For interfaces, we can't create objects, and for abstract classes also, we can't create objects. But that's why there must be one class which extends this class. Otherwise, there is no use of this program. If you write only interface and if you write only abstract class in the same program, there is no use. Okay, suppose if inside one program, if you define only interface like this and abstract class like this, there is no use of this program. Why? Because for interfaces and abstract classes, we can't create objects. Unless you create the objects for interfaces and abstract classes, you can't access the members of the interface and abstract class. So if you write only these two, that is interface I1 and abstract class A, there is no use of this program. That's why compulsory we must write one class. This is concrete class which extends that abstract class. So inside this class, or using this class object, or using B's class object, we can access the members of both the interface I1 and the abstract class A using upcasting. So this class B plays very important role in this program. This is must. Okay. Now understand class B. Class B extends A. Extends A means what? Here A is abstract class, no? A is abstract class. That's why inside this abstract class, one abstract method is there, no? That's why whenever this class B extends A, the role of this class B is it has to provide the implementation to this abstract method of class A. That is must. That's why it is providing the implementation to that abstract method, that is M2 here. This is must. And after that, it can write its own methods inside class B and it can write its own variables. Otherwise, class B consists of all the members of the interface and abstract classes and abstract class. Okay. So class B contains all the members of the interface I1 and the abstract class A. Because here I have taken abstract class A implements I1 now. That means here inside class A, all the members of I1 are available. That means when this class B extends A means all the members of this class A are inherited to this. All the members of class A are nothing but class A's own members and interface I1's members. That's why class B contains all the members of class A and the interface I1. Okay. In addition to that, it can write its own members, but here we have not written. So here inside class B, we have simply implemented, yeah, we have given the implementation to the abstract method M2 of this class A. That's it. Okay. Now here we have one interface I1 and one abstract class A and one concrete class B. Okay. Now here the question comes into picture. That is, for abstract class I1 we can't create object, and for interface for abstract class A we can't create object, and for interface I1 also we can't create object. That's why try to understand upcasting concept. So I will take one more class. Here I will use upcasting inside the main method. I will use upcasting concept to access the members. That's why what is upcasting? Upcasting is what? New B. New B means what? This is the B's class object. So whenever you use new operator means that is nothing but object creation. Okay, memory is allocated for this class B. Okay, using this new operator. So this is the object for class B. Now I want to access the members of the interface. So what I will do is I will use upcasting between this interface and this class B. So new B is the class B's object. So subclass object is assigned to, or implementing class object is assigned to interface reference variable. With this reference variable I can access all the members of the interface. So that's why I have written I1.a, because A is a static variable, that's why I can use interface name also. For static variables, we can access outside that interface using object or using reference variable or using the interface name also. So I1.a or I1.a, and inside the interface I have two methods, that is M1 and M2. So using this reference variable I1, I am accessing the members of the interface, that is A, M1 and M2. That's it. So this is nothing but upcasting. Similarly, you can create objects for class A and class B also. But for class A, we can't create object now because class A is this abstract class now. So how do I write? How do I access the members of class A? Is using B also we can access, or the other way is A1 is equal to new B. Means subclass object is assigned to superclass reference variable. With that reference variable, I can access all the members of the class A. So what is upcasting between classes A and B is capital A1 is equal to new B. So in place of I1, write A1 is equal to new B. And one more object we can create only for B, that is B1 is equal to new B. So here we can create three types, that is I1 is equal to new B, and second one is capital A1 is equal to new B, and B1 is equal to new B. So understand the difference between these three statements. You practice in the lab. Okay. Next, what is the next program? Next program is fourth program I am taking. So 7 programs you try to write on your own on interfaces. Once you understand the concept, you can write the programs on your own only. What is the fourth program? See this. So I am taking 2 interfaces and I am taking one class, and after that I will take one more class B which extends this class, means inheritance, and which implements I1, I2. Here in the same program, for the same class, I am using extends and implements. Here there is no comma. Right? Class B extends A and implements I1, I2. Means the role of this class B is all the members of class A are inherited to this class B using extends and implements I1, I2, means the class B has to provide implementations to all the abstract methods of I1 and I2. That's it. Now we will write the program for that. Complete all the 7 programs. Now I have to define 2 interfaces now in the fourth program. So first I define one interface I1, next define one more interface I2, next one class A. After that take one class B which implements I1, I2 and which extends this A. Okay, this is the figure. If you understand this figure, we can write the program accordingly. So interface I1, inside the interface I1 I am taking one final variable A and one abstract method M1. Next, inside the interface A, I am taking one final variable B and one abstract method M2. So here I have defined 2 interfaces. I1 consists of one variable A and one method M1. In the same way, I2 consists of one variable B and one method M2. Okay. Next, I will write one more class, that is class A, only independent class. Okay. Now class A, inside class A, I am writing one method M3. So I have given implementation to this method M3. It is saying that it is A's M3 method. Okay. Now if you understand the definitions of this interface I1, next interface I2 and class A. Okay. So with these two interfaces and this class, I will take one more class. So that is class B. Okay. What is the purpose of writing this class B is it extends class A and implements the two interfaces I1 comma I2. There is no, here it is, dot is there. Class B extends A, implements I1 comma I2, that's it. Next. Now what is the role of class B is it has to provide implementations to all the abstract methods of these two interfaces I1 and I2. Already explained in I1 we have one abstract method M1 and in I2 we have one abstract method M2. So here inside B we have to provide implementations to two abstract methods M1 and M2. Okay. Now here inside class B I am providing implementation to M1 and here I am writing B's M1 method because here it is implemented now, this method. Next M2 is B's M2. So class B is providing implementations to two abstract methods M1 and M2 of I1 and I2. Next, here extends A is simple only, no? All the members of this class A are inherited to class B. Inside class A we have only one member, that is M3. So M3 is inherited to class B using extends keyword. So inside class B we have the implementation for M1 and implementation for M2. M3 is inherited as it is. Okay, so M1, M2 and M3 we can access with this class object, and in addition to M1, M2 and M3, okay, we can write its own members. That means it is writing M4 method. Okay, that is this own method of class B. So if you understand class B, inside class B we have two methods. Okay, these two methods are in these two interfaces now. So class B can access M1, M2 and M3 also. Why? Because using extends A means M3 method of class A is inherited to class B. That's why we can use M1, M2, which are the methods of I1 and I2, and M3, which is the method of A, and M4, its own method. So using B's class object, it can access M1, M2, M3 and M4 also. Okay, that is the advantage of class B by using extends and implements keywords. Now take one more class test and write the main method. And now how do we access the members of the interfaces I1 and I2? Now this is the important question. Okay, here inside I1 I have one variable A and one method M1, and inside I2 I have one variable B and one method M2. Now how do I access the members of interfaces I1 and I2? Because for interfaces we can't create objects with new operator. That's why the solution for that is upcasting. Because here class B implements I1 and I2, no? That's why see, I can create only object for class B. That's why new B is the B's class object. It is assigned to the interface reference variable. That's why I1 is equal to new B. So with this reference variable, I can access all the members of this interface I1. In the same way, a new B, the B's class object is assigned to the second interface reference variable. That's why second interface is I2 is equal to new B. So with this reference variable I2, I can access all the members of this interface I2. Why I am assigning new B to both I1 and I2 is I1 and I2 reference variables is here. If you see this syntax, class B implements I1 comma I2. That's why class B of B's class object is assigned to this interface I1 reference variable, and B's class object can also be assigned to this interface I2's reference variable. Okay, understand this. B implements both I1 and I2. That's why B's class object is assigned to interface I1's reference variable and also interface I2's reference variable. So with this syntax or with this I1, I can access all the members of the interface I1. That's why here with this I1, I1 dot A, because A is a static variable outside the interface, we can access static variables with interface name also. So reference variable we can use or interface name also we can use for static variables. That's why I1 dot A, I1 dot A. Next, inside I1 we have only one abstract method now, that is M1. That's why I1 dot M1. That's it. If you write I1 dot M2, it will give you error, because with this reference variable we can only access all the members of I1. That's it. We can't access the members of B also. But what is the upcasting? If we assign implementing class object to interface reference variable, with that reference variable we can access all the members of this I1 except overridden methods. See, all the abstract methods of this interface must be overridden inside the implementing class. That's why in case of overridden methods, B's class overriding methods will be executed. If you write I1 dot M1, you will get the output is B's M1 method, because M1 method is implemented inside class B, no? That's why you see the upcasting. Upcasting with respect to interface and class is implementing class object is assigned to interface reference variable. With this reference variable, you can access all the members of the interface except overridden methods. See, all the abstract methods of this interface I1 are overridden inside class B. That's why with respect to methods, only B's class methods will be executed. With respect to variables, I1's variables are executed. Okay, you remember this point. With respect to variable, interface variables are executed. With respect to methods, this B's class methods will be executed with this statement. Now that's why if you take this I1 dot A, interface variable is A, that is assigned with 10. So you will get the output as 10. And this is also 10. Next, if you take this method M1, M1 is not implemented in the interface I1, but it is implemented in the class B. That's why except overridden methods, no? That's why in case of overridden methods of I1, this overriding methods of class B will be executed. That's why I1 dot M1 means you will get B's M1. Means M1 method is implemented inside the class B. This is called overriding method. That's why use in the upcasting, please remember the condition except. Again, I am repeating upcasting with respect to interface and with respect to class. Implementing class object is assigned to interface reference variable. It is nothing but upcasting. With this reference variable, we can access all the members of the interface except overridden methods. Because all the methods of the interface are overridden methods only. Why? Because inside the interface we can write only abstract methods. So in interface consists of 100% abstract methods. Inside interface we can't write concrete methods. That's why all the methods of the interface are abstract methods. Means all the methods of the interface are overridden methods. Overridden means inside the implementing class we must give implementation to the abstract methods. No, these methods are inside this class B. Those methods are called overriding methods. Now I am repeating upcasting between interface and class. Implementing class object is assigned to interface reference variable. With this reference variable, you can access all the members of this interface except overridden methods. So in case of overridden methods, subclass overriding methods will be executed. That's why if you see the output, interface reference variables are executed and implementing class methods are executed. That's why the answer will be the interface reference variable is A. That's why 10, 10. And if you take this M1, this overriding method M1 of B is executed. That is B's M1. In the same way, I2 is equal to mu B. Here with this reference variable I2, we can access all the members of I2 except overridden methods. That's why the output is. So if you take variables, interface variables are executed. If you take methods, implementing class methods are executed. That's why B is 2020 and B is M2, right? Next, in the same way, we can create objects for A and B. This is normal. This is inheritance. This is normal. So So with this reference variable A1, I can access only members of A. But with this reference variable B, I can access all the members of the interfaces and also this class A. Because what is class B? Class B extends A and implements I1 and I2. No? So if you create object purely for class B, okay, if you create objects purely for class B, so with the class B's object, I can access all the members of the interfaces I1 and I2 and also all the members of this class A. So this is the like subclass object. With this subclass object, I can access all the members of interfaces I1, I2 and class A and its own members. Here you can write all those. Okay, so this is the program using extends and implements. Okay, next program is here I am defining two interfaces. Simply you can write like this, because public, static, final are available for this variable and public and abstract are available for this method. Simply you can write interface like this without writing public, static, final here and public and abstract here. So this is the interface I1, which is defined with one final variable and one abstract method M1. Abstract methods must end with a semicolon. There is no body for abstract methods. And the same interface I2, it consists of one final variable B and one abstract method M2. So these are the two interfaces. Already explained, no? Between interfaces we can use extends keyword like classes. One class can extend only one class in Java, but one interface can implement any number of interfaces. One interface can extend any number of interfaces. Between classes and between interfaces we can use extends keyword. So here I am defining one more interface I3, which extends both I1 and I2. This is nothing but multiple inheritance. Through interfaces we can achieve multiple inheritance in Java. That is nothing but this. But if you take class A extends B, C, we can't write. Class A extends B, C, we can't write, because in Java one class cannot extend more than one class. One class must extend only one class. That's why multiple inheritance is not possible in Java. But through interfaces we can achieve multiple inheritance. That is nothing but this statement. That is, one interface can extend any number of interfaces. 10 interfaces also it can extend. Between interfaces we can use extends keyword. Between classes also we can use extends keyword. But between one class and one interface we can use implements keyword. First you need to understand these two keywords, or the importance of these two keywords, that is extends and implements. Okay, so here interface I3 extends I1 and I2. What is the meaning of extends? Is inherited only. So all the members of I1 and I2 are inherited to I3. In addition to the inherited members, I3 can write its own members. So what are the inherited members of I1 and I2? To I3 are A, M1, B, M2. So inside I3, A is available, M1 is available, and B is available, M3 is available. But here the important point to remember is these two are abstract methods now in interfaces I1 and I2. So abstract methods are inherited to this interface as it is. Means this M1 method is inherited to this interface like abstract only. So in addition to the inherited members of I1 and I2, I3 can write its own members. The own members of I3 are C and M3. You know, M3 also abstract method, because I3 is an interface, not class. So inside I3, I have two members, own members. They are C and M3. Now, if you now the question is, what are the members? Okay, which are there inside the I3. What is the answer for this? What are the members of I3? So the members of I3 are A, with respect to variables I will explain first. A is equal to 10, B is equal to 20 and C is equal to 30. These three are the variables which are available in interface I3. Next, if you take methods, the abstract method M1 and abstract method M2 and abstract method M3. So three abstract methods, that is M1, M2, M3 are available inside I3, and three final variables are available. They are A, B, C. So inside I3, I have three final variables A, B, C, and 3 abstract methods M1, M2 and M3. Okay, that is the interface I3. So through this extends keyword, I can inherit all the members of this I1 and I2. Means I3 inherits all the members of I1 and I2 using extends keyword. So the members of I3 are 3 variables ABC and 3 abstract methods M1, M2 and M3. So inside I3 I have 3 final variables ABC and 3 abstract methods M1 and M2, M3. So inside I3, 3 variables and 3 abstract methods are available now. So we must take one implementing class which should implement I3 now. That's why I am taking one class. If you write only interfaces, there is no use no. If you write in the program simply interface I1, interface I2 and interface I3 extends I1, I2. What is the use? For interfaces, we can't create objects now. We can only create reference variables. So without creating objects for the interfaces, how do I access the members of the 3 interfaces I1, I2 and I3? It is not possible. We can't access the members. That's why the class A is important here. There must be one class which implements I3. If this class A implements I3 means I3 is having all the 3 final variables and all the 3 abstract methods now. That's why only write implements I3. That's it. Suppose if you write class A implements I1, means it will give implementations to only one abstract method now. But here I3 extends I1 and I2 means inside I3 we have all the members of I1, I2 as well as I3. That's why if you write class A implements I3, it is meaningful. Means all the members of I1 and I2 and I3 are available inside class A if you write implements I3. If you write implements I1 means only I1 members. If you write only I2 means only I2 members. But if you, because here interface I3 extends I1 and I2, no? So if you write implements I3 means all the 3 interface members are available for class A. Now what is the role of class A is, it has to provide implementations to all the abstract methods of these 3 interfaces, I1 and I2 and I3. It has to provide implementations to all the abstract methods of I1, I2 and I3. If you write implements I3, because inside I3 I have 3 abstract methods M1, M2, M3. That's why when you write class A implements I3, class A has to provide implementations to all the 3 abstract methods of I3, that is M1, M2 and M3. That's why inside class A I have provided implementations to M1. This is the implementation of M1. This is the implementation of M2, because here we are implementing this M1 method inside class A. That's why here I have written ASM1 method. Next ASM2 method. It is giving implementations to M2 and also to M3. In addition to providing the implementations to all the 3 abstract methods of I3, it can provide its own it can write its own methods, that is M4. So M4 is the own method of class A, whereas M1 and M2 and M3 are the methods of the interface I3. Because I3 implements I1 and I2, means I1 and I2 abstract methods are inherited to I3. So I3 has 3 final variables and 3 abstract methods. That's why whenever this class implements I3, it has to provide implementations to all the 3 abstract methods M1, M2 and M3. That's it. And inside class A, we can access 3 final variables. They are A, B, C. Okay. Next, I will take one more class, and I will use upcasting to access the members of I3, because I3 consists of all the 3 abstract methods. No need to take I1, I2, I2, because I1, I2, there is no use, because I3 consists of both I1 and interface I1's members and interface I2's members also. That's why with I3 I can access all the interfaces. All means I1's members and I2's members also. That's why I will use upcasting between the interface I3 and the implementing class A. So between this interface and this class, I will use upcasting. So upcasting can be used 2 ways. Between 2 classes we can use, that is abstract class and concrete class. And between interface and implementing class also we can use. So upcasting can be used 2 ways, that is between classes we can use, means subclass object is assigned to superclass reference variable. This is with respect to abstract classes we can use upcasting, And in the same way, we can use upcasting to access interfaces members. That is, between interface and class A also we can apply upcasting. It is nothing but implementing class A is implementing class object is assigned to interface reference variable. This is also upcasting. So upcasting is used with respect to abstract classes and with respect to interfaces. That's it. So I3 is equal to new A, means implementing class object is assigned to interface reference variable. With this reference variable I3, we can access all the members of I3. Already I explained interface I3 consists of 3 final variables A, B, C and 3 abstract methods M1, M2, M3. So with this reference variable, I can access 3 variables A, B, C and 3 abstract methods M1, M2, M3. That's it. If you access M4 with the reference variable, it is error. Why? Because with this I3, I can access only the all the members of I3 only. Already explained many times. The members of I3 are 3 final variables A, B, C and 3 abstract methods M1, M2 and M3 only. So with I3, I can access 3 final variables A, B, C and 3 abstract methods M1, M2, M3. But here what I have written I3.M4 because M4 is the own method of this class A. So M4 method cannot be accessed with this reference variable I3. Okay, with upcasting. So with this I3, I can access all the members of I3, but M4 is not a member of I3. So I can't access M4 with I3. That's why if you write like this, you will get compiler error. So with this, the output is 10, 20, 30, and M1 is ASM1 method, M2 also ASM2 method, M3 also ASM3 method, because all these 3 methods are implemented inside class A. These 3 methods are called overriding methods inside class A, and these 3 methods are called overridden methods inside the interface I3. So subclass, the implementing class object is assigned to interface reference variable. Then with this reference variable, you can access all the members of this interface except overridden methods, because all the 3 methods of this interface I3 are called overridden methods. So in case of overridden methods, implementing class overriding methods will be executed. That is the reason. Okay, what is the output of this? ASM1 method, and this is ASM2 method. It is ASM3 method, because all these 3 methods are called overriding method in case in class A, and all these 3 methods are called overridden methods inside the interface I. Okay, in case of upcasting, overriding methods will be executed. Okay, here the variables are same only 10, 20, 30. Similarly, you can create object for class A. With this class A's object, we can access all the members of the interfaces I1, I2, I3 and also its own member M4. So with this A1, you can write A1.A, A1.B, A1.C and A1.M1, A1.M2, A1.M3 and also A1.M4, because M4 cannot be accessed with I3 now. But by creating the object purely for class A, with this A1, it can access all the members of the class A. That's why I have written only M4. But actually with this A1, we can access 3 variables A, B, C and 3 methods M1, M2, M3. In addition to that, it can access its own member, that is M4. Here it cannot be accessed, but here it can be accessed. Okay, that's it. With this interfaces, see the output. With this interfaces programs are completed. And next class, I will explain garbage collection.